So we'll be going over the warm-up now. Make sure you have your grading utensils out. I know this wasn't one of your homework problems, but hopefully you thought back to what we did work on in 9-1 and were able to look at these equations and identify if they would have one solution, which means they would cross once, infinitely many, which means they would be the same line, or no solution, which means they would be parallel and they would never cross. So on number 1, the first thing to notice is they're already in y equals form, so we don't have to do any solving for y. Well, the first thing we look at are the slopes. So in the first equation, the slope is 3. And in the second equation, our slope is -2. Well, that is all the information I need to know from here, because this tells me that since the slopes are different, that the lines would cross once, which means they would have one solution. Now number 2, we can't tell yet because we need to solve each equation for y. So I'm going to take the first one, 2x plus y equals 4. To get y by itself, we would subtract 2x. So I would have y equals -2x plus 4. So there's equation number 1. Working on equation number 2, 4x plus 2y equals 8. So you should have subtracted 4x. And you would have had 2y equals -4x plus 8. Well, y is still not by itself yet, so we would divide everything by 2. And y equals -2x plus 4. So I look at my two equations, and hopefully you noticed that they're exactly identical. Well, if they're exactly the same, that means on a graph they would have the same line, which means for an answer we would be looking at infinitely many. Now, some of you might have noticed at the beginning that if I took this equation and multiplied it by 2, I would get this equation. If you notice that, that's great. Yes, that also works. Just make sure that everything multiplied by 2 would be this. If even 1 is off, it wouldn't be infinitely many. So just make sure you take your time and look at that if you're going to try to shortcut it. Here are the answers to the problems you were working on in class yesterday and finishing for homework. Number 6, they should have crossed at 2, 4. And the equations were y equals -2x plus 8 and y equals x plus 2. So here's the x plus 2 line, and here's the -2x plus 8. Going ahead and looking over to the right at number 9, the two equations were 1/3 x minus 1, which is this one, y equals -x plus 5, which is this one going down. An approximate solution, it's just past 4. So if you put 4.25, 4.4, even 4.5 is fine. And then it's just a little past the 0 mark, so anywhere around 0.5. If your lines are off, probably the biggest thing is look at the one with the negative slope. And remember that negative is only one negative direction, because 2 negatives make a positive. Moving on to the next two that you can see here, 7 and 10. 7, the answer was -4, 1. Your two equations should have been y equals -1/2 x minus 1 and y equals x plus 5. Here's the -1/2 x minus 1 and the y equals x plus 5. Number 10, after you graphed, you started classifying it using those vocab words. On number 10, make sure you remember if there's just an x, that's always a vertical line at x equals 2. And then the other equation was y equals -1/2 x plus 3, which is this one going down. Since they cross at one point, they're consistent and independent. It didn't ask us to solve it, so we don't need to tell the solution. Number 8, the lines were negative 1/2 x minus 1 and negative 1/2 x minus 4. If you think back to your warm-up, you probably should have been able to notice, hey, same slope, but different y-intercepts, which means they're not the same line. They're not going to cross. So parallel lines, which is no solution. Number 11, the lines ended up being the same, 2x plus 6, which means it is consistent because it does have solutions, and it's dependent because it's the same line, they depend on each other. And remember, if they did ask you for the solution, this one would be infinitely many. The next page, 12, 15, and 16. Number 12, the solution was 2.5 and 4. Well, it then asks us to write the equations. The vertical line, that's pretty easy. Vertical is x equals, and it's at 2.5. The next one starts at about 1.5, and the slope is about up 1 over 1. So 1x or just x. 15, to check your answers, you substitute them and evaluate. 16, you have a vertical and a horizontal line, which means they cross where the values are. The value has to be 3 for x and 4 for y. 14 is sometimes, because if the y-intercepts are different, they can be parallel lines, which would mean no solution. 17, to recognize a dependent system, the equations are equivalent. If two lines have different slopes and the same y-intercept, then that still means there would be a solution, consistent and independent, and the solution would be the y-intercept, which is where they cross. 19, they gave you the two equations, so you just had to graph them. Ignore the extra dot there. And they cross at 2 hours and $20. Number 20, y is the total number of miles, x is the number of weeks. And they didn't ask you to solve it, so all you had to do was state that and you were done. The last two, 21 and 22. 21, he says it's inconsistent, which would mean no solution, but it is consistent because it's different slopes. It doesn't matter about the y-intercept, it matters about the slope to have solutions. And on 22, could you find the solutions without graphing? Well, different slopes, the same y-intercept. You know that the lines cross at that same y-intercept, which would be your solution. So we're still solving linear systems. We're learning our second method, which is what we call substitution. Now remember, the first method is graphing. Graphing, we learn it first because we need to see the visual of what we're looking for here. But to be honest, it's typically not the method we fall back to when we're solving. So the algebraic methods, first one substitution, and then what we learn in a couple days is generally what we use to solve. But again, we needed to understand that you could either have one solution, which is where the graphs cross once, no solution, which is where the graphs don't touch, or infinitely many, which is where they end up being the same line. So we have an explore activity, and they give us two equations here, y equals 3 and x plus y equals 5. So the first thing you're going to do is substitute the value for y in the second equation and solve for x. So go ahead and do that, check with your neighbors, and then unpause this. So we know that y in this case is 3, because that's what it tells us. So we take the y and we substitute it with 3. So I know that if x plus 3 equals 5, then that means x has to equal 2. And that's your basis for substitution, replacing something with another number in this case, or what we're going to be working on today are expressions. Well, part B says since we know the values of x and y, what's the solution? Well, solution would be what our x and y are, which is 2 and 3. 2 is what we found, 3 is what they gave us. And part C says to go back and to graph the system of linear equations. So go ahead and graph those. Take a few minutes. I'm not going to be able to graph them on here, but you know that you're correct if they cross at the point 2, 3, and you can compare it to your group members. So go ahead and do that, compare, make sure it ends here, and then unpause this so we can do part D. Well, now in part D, we're given a new set of equations. Remember, a system will always have 2 for us. They can have more, but this year we're sticking with 2. And it says that we're substituting in for y. Well, think about this. In the first case, y equaled 3 in part A, and here in part D, it equals 2x. Well, we're still going to do the same thing. We're going to take the 2x and plug it in for y, because that's what 2x is equal to. So I'm going to rewrite the second equation, 2x plus 3, but I don't want to write y. I want to write what I know y is equal to, which is 2x. And then we continue writing the rest of the equation, which is the equal to 40. So now I can simplify this. I have 2x plus now 6x equals 40. Well, 2x plus 6x, they're on the same side, so we know that's 8x. To solve for x, we would divide both sides by 8. So x equals 5. Well, now I need to find what y is. Well, I know that at the beginning it told me that y was equal to 2 times x. Well, I now know what x is. So if I multiply that by 2, I know that y equals 10. And that's a basic substitution problem. Now we have some reflection questions. So go ahead, answer part 1 and 2, check with the neighbor, and then unpause this when you're ready to check your answers. So number 1, when you substituted 2x in, that was where we got this part right here. So you could either, so this would be your answer, 2x plus 3, 2x equals 40, because remember we took y out and replaced it with y. Now it does say after we also simplify it, so simplifying it we could have turned this into 6x, so you could also have answered 2x plus 6x equals 40. To check your solution in part D, well, you would replace x and y with our solution 5 and 10, not into just one equation, but into both. Well, we would say for the first one that y, which is 10, is that equal to 2 times 5, which is x? Well, 2 times 5 is 10, so that one checks out. But it's not just about one of them working out, it's about both of them. So then we would also put it into the second equation. So we would go 2 times x, which is 5, plus 3 times y, which is 10. And we want to know, is that equal to 40? Well, 2 times 5 is 10, 3 times 10 is 30, 10 plus 30 does equal 40. So since it does work for both of them, we guarantee that it's the correct solution. So the substitution method, which is again what we just did a problem on, it's used by solving an equation for one variable and then substituting it into the other equation. Now, if one of the equations is already solved for, then that's the one you substitute with. Like for example, part D, it said y equal 2x, so y was solved for, so we could go straight to substituting. it doesn't matter if it's y by itself or if it's x by itself. In graphing, it always has to be y, but that's not the case in substitution. It can be either variable. So once one of the equations has a variable by itself, and you might want to write here x or y, we then substitute it into the other equation and solve for the variable that's left. Once you solve for that variable, you substitute the value into either original equation, whichever one's easier, and then you find the opposite variable. So if you found x first, we then plug it back in to find y, or vice versa. So those are your 3 steps, but again, in math it's usually easier to see the steps rather than just have them written down for you. Example 1, the book has a substitution problem worked out for you. This one's different than the explore activity because if you notice, neither of the equations has a variable by itself. When that happens, your goal is to find the equation where it'd be the easiest to solve for the variable. It doesn't matter if you solve for x or solve for y, whichever is easier. So if I look at the first equation, negative 3x plus y, which is the one they're working with, the easiest variable to get by itself would be y. To do that, you would take this negative 3x and add it over, which is how it became positive. Now, if you look at the second equation, it also would have been pretty easy to get that y by itself because you would have taken that 4x and subtracted it. Either way would be fine. They chose to take the first equation. But we wouldn't want to solve for one of the x's because you would have to do division, and our goal is to try to avoid that. We just usually want a one step to get a variable by itself. So then they said, okay, well, y is now the same thing as 3x plus 1. So in the second equation, where that y is, I'm going to take it out and replace it with 3x plus 1. So they solved for x where x equals 1. So those were your first 2 steps. Now bear with me on this slide, I put step 4 and step 3 backwards. So step 3, now that we know what x is, which was 1, we're going to substitute that back into either of the equations. They chose to plug it back into the first equation, negative 3x plus y, which equals 1. That one should be over there. And that gave them y equals 4. You also could have chosen the second equation. Either way would have been fine. Now, one way to check it is to plug 1 and 4 back into both equations and make sure they're true, or to graph them. And again, they're choosing to graph by intercepts. I think solving for y is easier, but it's up to you. But that is another way that you could graph, because remember, the solution you find when substituting, the 1, 4, is the same solution you would find if you were to graph those 2 lines. It means the same thing. So now looking at the equation here for your reflection questions, negative 3x plus y equals 1. Answer the 2 questions and then unpause this to check your answers. Well, would it be more efficient to solve negative 3x plus y equals 1 for x? That would definitely be, hopefully you said a no, because to solve for y, all we have to do is add the 3x over. But to solve for x, we would have to subtract y and divide. So it would be more steps to solve for x. And another way to check your solution is our first method of solving, which is to graph it. So we're going to do number 5 together, and then you're going to do we're going to do number 6 together, and you're going to do number 5 on your own. So on number 6, the first thing I look at are my 2 equations. Well, neither one of them have a variable all by itself, so this means we have an extra step. We have to get one of the variables by itself. It doesn't matter which equation, we look at the variable that would be the easiest. And the variable that would be the easiest would be this top x, because all I would have to do is subtract 3y, and x would be by itself. So I'm going to rewrite that equation. X plus 3y equals 4. And we're going to subtract 3y on both sides. If you're graphing, you have to have a y by itself. But in substitution, it doesn't matter. So x equals negative 3y plus 4. I'm going to go ahead and put the variable first because that's what we're used to doing. So since that was the first equation, we now take this value and we substitute it in for the second equation wherever we see an x. So it says negative, and then I see x, but I don't want to write x. I want to write what x is equal to, which is negative 3y plus 4. So when we substitute it in, we insert parentheses, negative 3y plus 4, and then I write the rest of the equation, which is plus 2y equals 6. So I'm going to, first of all, distribute this negative. So it becomes a positive 3y minus 4. And then bring down the rest, plus 2y equals 6. Well, I have like terms on the same side. I have a 3y that's now positive, plus 2y, makes that a 5y. Add 4. So 5y is equal to 10. Divide by 5, which means y equals 2. So that's half my answer. Remember, you always have to have two answers, one for x, one for y. So I look at either equation at the beginning, and I say, which one does it look easier to put that y in for and solve for x? And hopefully you realize it's the top one. So I'm going to go x plus 3y, but now I know y is 2, so that's 3 times 2 equals 4. So I have x plus 6 equals 4. Subtract 6, x equals negative 2. So when we write our solution, even though we didn't solve by graphing, it is still written as an ordered pair because it's still, if you were to graph it, where they would cross. So negative 2 and positive 2. And there's your solution. That's the hardest that substitution gets, when you have to solve for a variable and then replace it. So now let's go back and look at number 5. And hopefully you recognize that there is a variable by itself. If you didn't and you did extra work, it's okay, it would still work out. But I want you to go ahead, solve this, check with your neighbor as needed, and then unpause this when you're ready to check your answers. So the variable that was all by itself is this bottom y. So I know that in the other equation, wherever I see a y, I want to replace it with what it's equal to, which is x minus 4. So I'm going to go 2x plus, and then in parentheses, what y is, which is x minus 4, and it's equal to 5. Well, if I look at this parenthesis, there's nothing outside of it, and it's a plus sign, so nothing's going to change here. So this is just 2x plus x minus 4 equals 5. Hopefully you noticed you had like terms here. 2x plus x, well that's 3x. Add 4 to both sides. So 3x equals 9, which means your answer should be x equals 3. So we have half the solution. Well, we look at either equation to figure out where it'd be easier to put x in for. Hopefully you looked at the bottom one as being easier. So we would say y equals x, which is 3 minus 4, which means y equals negative 1. So your solution is 3 comma negative 1. Now this next part is still the same exact method, but it's how we get some of our special answers. Remember, there are 3 possible answers for a system. 1 solution, which is what we just saw because we got an answer for it. Now we're going to look at infinitely many and no solution. Well, we actually dealt with these with equations already. With infinitely many and no solution, your variables are going to cancel out. Notice how this negative y and this y cancel, and you're left with the statement of 2 equals 4. Well, obviously we know that that's false, which means it has no solution, which means on the graph, it would be parallel lines. If this statement was true, then we know it would be the same line, which means it would have infinitely many solutions. But the rest of it is just what we've already worked with. So in example B, they're giving you one where it is a true statement, -4 equals -4, which means it has infinitely many. And if you were to rewrite these equations in y equals form, you would notice that you would graph the same line. So go ahead, checking out part B for both 7 and 8, answer your 2 reflection questions, and then unpause this when you're ready to move on. So number 7, why is it more efficient to solve and substitute for y than to solve and substitute for x, is because there's less steps to solve for y. Does that mean you couldn't solve for x? No, but why do more work than you have to? Part A says, say you have 2 possible solutions of the system. Well, since there's infinitely many, as long as it's an ordered pair that's on that line, it's a solution. So check with a neighbor, have them check your ordered pair, make sure that it does end up on the line, check theirs as well, and then that's a solution. There's an infinitely many, so really and truly every single person could have a different answer. So last 2 problems of the day, 9 and 10, we're going to do 10 together, and then you're going to go back and do number 9. If I look at number 10, we're looking for a variable that's easy to solve for. Well, if you look at the x's, you know you're going to be dividing, which means we don't want to do that. The y's, both of them are by itself with a negative, so it doesn't matter. So I'm going to pick the top one. 2x minus y equals -1. Well, to solve for y, we're going to subtract 2x. So I now have -y equals -2x minus 1. Well, y is still not by itself, so we divide everything by -1 since it's negative. And I get the equation y equals 2x plus 1, since 2 negatives make a positive. So now I'm going to take this and substitute it into the second equation. So the second equation starts off as 2x minus, and then it's y. Well, we know that y is 2x plus 1. And then I continue writing the rest of my equation, which is equals -4. So now we take this negative and distribute it. So I bring down the 2x, and this becomes minus 2x minus 1 equals -4. Well, 2x minus 2x is going to cancel. So we're left with -1 equals -4. Well, -1 obviously doesn't equal -4. So since the variables canceled and we were left with a false statement, that means our solution is no solution. So now go ahead, work on number 9, check with your neighbors as you go along, and then unpause this when you're ready to check your answers at the end. So on number 9, hopefully you found that the easiest variable to solve for was this x. You could have solved for any of the others, but they all would have made it harder. So I'm going to rewrite x plus 3y equals 6. You should have subtracted 3y and got x equals negative 3y plus 6. So we're going to take this and replace it into the second equation where I see that x. So it's 2 parenthesis negative 3y plus 6. Bring along the rest of the equation. So now for this one, you should have distributed that 2. So it's negative 6y plus 12 plus 6y equals 12. Well, negative 6y and a positive 6y are going to cancel. So we're left with 12 equals 12. This time, hopefully you notice that that's a true statement. So since the variables cancel and we're left with a true statement, that means your solution is infinitely